Today, you're going to learn how to find the average rate of change of a function. Okay? And you have it, your foldable, how you can write the average rate of change. All four or all three of those formulas say the exact same thing. You probably know this one the best though. This one down here. What is that the formula for? Slope. That's the formula for slope between 2 points. That is what the average rate of change is. The average rate of change is the slope of a function. Now, what you guys are probably thinking, well, slope deals with lines, right? Maybe you were thinking that. Slope deals with lines, yeah, it's fine. Well, calculus, my pre-calculus students, okay? This is one of these like underlining concepts to prepare you for calculus, okay? One concept is called derivatives, and what you are basically doing is finding the slopes of curves. That's what you do in calculus. Now, this concept here, average rate of change, is like that pre-part before you can actually do that. Okay? So if you understand this concept, then you're one step closer to understanding a major concept in calculus. Sound good? Pre-cal? Awesome. But we don't use that old school formula because this was geometry. Okay? This was geometry. This right here is pre-cal. Okay? And what this basically is saying is your function, when you plug in one value, subtracted from the function when you plug in a different value, divided by whatever those two values were, the difference of them, gives you your average rate of change. It gives you the slope between those 2 points, okay, that are somewhere on the curve. All right? So we're going to look at 4 different ways of how you find the average rate of change. The first one is given a graph, okay? And here are your steps. It's a Friday, so everything's filled in, okay? It's Friday pep rally, no less. So we're going to find the points on the graph at each given x value. Then we're going to write the ordered pairs, and then we're going to plug in our x's and our y values into the average rate of change formula. So again, the average rate of change formula, I'm just rewriting it because it's not on this slide. You guys have it literally right above you, is this. Remember, f of a value gives you basically the y point of that respective x value. Okay? Just like what you guys did in your do now. So these give you the y values. A and B are basically your x values. That's why it's very similar to slope. You're subtracting your y's and you divide it by from your x's. Okay? So the example that we have is we are going to find our average rate of change from 1 to 3. Okay? So from the x value of 1 to the x value of 3, we're basically trying to figure out what is the average rate of change. What is basically the slope of the line that connects those 2 points. Okay? So step 1, we found them. Now we need to write the ordered pairs. This point down here is 1, 1, and this point up here is 3, 9. Okay? Now we plug in our x and our y values into the average rate of change formula. Okay? F of B needs to represent one of those y values, and f of A needs to represent one of those, the other y value. Which one do you want to do first? Because it does matter. 9. Okay, so we're going to do 9. That represents f of B minus 1, which represents f of A. And now we're going to divide it by B and A. B minus A. So it's going to be 3 minus 1. It does matter because if you flip them, if you did 1 minus 9, then on the bottom you had to do 1 minus 3. Okay? So what's 1 minus 9? Or sorry, 9 minus 1? 8. And what's 3 minus 1? What's 8 divided by 2? 4. So your average rate of change is 4. The slope of the line that connects those 2 points is 4. Okay? That was the easy one. Good? Let's look at it from a table. These are all the steps to help you, okay? Because there's a lot of other things that are in your graph or in your table that can be distracting. You want what you want. It says circle the x and y values on the table that match the x values in the given interval. You want to write the ordered pairs. Plug in your x and y value again into the average rate of change formula. We want to find the average rate of change for the interval 1 to 4. So, if I'm looking for 1 to 4, it's almost like on a graph, here's 1 and here's 4. I want to find that. But it's not given to me as a graph, it's given to me as a table. So, I need 1 and I need 4. And again, we're plugging this into our average rate of change formula. What's f of b? 1. What's f of a? Negative 11. Remember, f of b and f of a represent the y values. So it's f of b minus f of a, so be careful, all over b minus a. What's b? 1, and what's a? 4. Again, make sure that if you do it this way, it matches up correctly. A negative and a negative make a? 11. So what's 1 plus 11? 12. And what's 1 minus 4? And what's 12 divided by negative 3? So there's your average rate of change on that particular interval. The average rate of change is basically telling you how quickly the graph is either increasing or decreasing between those 2 points. Okay? Let's look at it from a function. Is everyone okay so far? Graph is pretty simple. You just got to find the y values. Table's even easier. You just got to pull out the information. Okay? When it's a function, that's where you actually got to do a little bit of work. Okay? Because you need to substitute in the x value into the function to find the corresponding y values. So what we did yesterday, we basically have to apply today. All right? And then again, we plug it into our average rate of change formula. So we need to know what f of 2 is, and we need to know what f of 3 is, because those answers are going to be our numerator in the average rate of change formula. Okay? So can you guys do f of 2 and f of 3 for me, please? F of 2. Erica, what you get for f of 2? 8. Larry, what you get for f of 3? 13. Yes? Awesome. So now we're going to plug into our average rate of change formula. Instead of using B's and A's, let's actually use the respective numbers. Which one do you want to make first? The 13 or the 8? 13. The 13. So if I do that, I'm going to do f of 3 minus f of 2. So then it's going to be all over 3 minus 2. Okay? You don't have to write this step right here, the one that I just wrote. I'm just doing it, if anything, for the video's sake. Okay? Just in case someone who's watching might not understand. All right? Or even for the quiet one. Okay? F of 3 is 13. F of 2 is 8. And I'm going to do 3 minus 2 on the bottom. So my average rate of change from x equals 2 to x equals 3 is 5. How is this?
So it doesn't matter which one goes first?
You just want to make sure that if you, let's say you did 8 minus 13 instead, you got to do 2 minus 3. You got to do it, but just don't end up with the same answer. Because now you got negatives. Good? Yes? No. Great question. It won't always be a whole number. Okay? It won't always be a whole number. But as long as you do the formula, you're good. Okay? I think for this one, all. Now, let's take a look at this one. Given function notation. Step 1. The numbers inside the parentheses are your A and your B. They are your x values. You want to subtract those two numbers in the denominator of your equation. The solution is the change in your y's. It is your numerator. And all you got to do is simplify your fraction. So you're finding the average rate of change given f of 5 minus f of 3 equals negative 10. Indirectly, they gave you A and B. Do you guys see that? What's B or A? What's A? A is 3 and B is 5. So this is nothing but f of B minus f of A, and they basically gave you your numerator. It's negative 10. The only thing you have to do now is the denominator. And what goes in the denominator? The x's. 5 minus 3, B minus A. Did everybody catch that? Like the only thing we're missing in this is the B minus A part. Okay? 5 minus 3 is? A little louder? 2. And what's negative 10 divided by 2? So then the average rate of change for this particular function, whatever it was negative 5. And that, you guys, is how you find the average rate of change given a function, a graph, a table, or the notation.